Hello, scientists. Today we're going to be reading an article that's all about light and sound waves, but I thought I would make a video to read it along with you because there's so many neat concepts that this article talks about, and if we don't really put them into action, you might not appreciate how truly cool they are. So let's jump in and read this article together. The article starts like this: light and sound waves. Energy travels through matter in waves. Now we've seen that with our water display, where you can see if wind gets blown across a wave or a disturbance is made, the waves can be smaller in amplitude or higher in amplitude. The wavelengths might be really close together and short or really far apart, right? So we can see that, how energy can travel through waves. But ocean waves aren't the only kind of waves, are there? There's also light and sound waves. Light and sound waves travel through matter. We cannot usually see light or sound waves, but we can sense light and sound in many ways. Let's start by looking at light. Light is a form of energy that travels in waves. Light energy is unique because it does not need matter to travel. Light can travel through space. How many of you have heard that expression, light years? That means if I was to shine a light, the distance that it would travel in the span of a year is the distance of 1 light year. So if I turn on a flashlight right here and send it off into outer space, wherever it would reach in 1 year is 1 light year away from me. Pretty cool, right? Color. One way that we can see light energy is through color. Have you heard of the color spectrum? It is related to the rainbow. Red, orange, yellow, green and blue, indigo, violet too. As you move across the color spectrum, wavelengths of light waves decrease. In other words, wavelengths get closer together and the frequency increases. So remember, if we think of a wave across the ocean, if our wavelengths are really close together and frequent, they are like this, really tight waves that are close together as opposed to longer waves that are farther apart. Here in this picture, we have a rainbow. You can see the colors red, orange, yellow, green, blue, indigo, and violet. But if we look at them in the form of waves in this image below, you can see that these wavelengths for each color are actually very different. For red, the wavelengths are really far apart. And as we move from one end of the rainbow to the other, those wavelengths get really tight and shorter. They're closer together. Let's look at this section. Light behaves in different ways. Reflection. Light waves bounce off a surface back to your eyes. Mirrors and other shiny surfaces do this. Try taking a flashlight into the bathroom and shining it at your mirror. You'll see that light reflected back. You can even play around with shining a light, reflecting it in different angles so that it can hit your face, it can hit the wall behind you. Play around and see where you can direct that light by reflecting it off of that shiny surface. Another interesting way that light behaves is refraction. This is when light waves bend through an object. This changes how we see the objects. Look in a water glass to see it. Now here I've done just that. I put a pencil inside of a glass of water, and I want you to see how at different angles it almost looks like an optical illusion, where my pencil looks like it's being split into 2 pieces. That is refraction. Try this at home yourself. Another way light behaves is absorption. Light waves get taken in by an object. This shirt is absorbing blue light, so it looks blue to us. You want to study something really cool about wavelengths? It's right here. Right here, you'll see my wrist, and inside my wrist, you can see my veins underneath the skin. Sorry if that's a little icky for some. These veins are those tubes that are underneath your skin that circulate your blood around your body. From the outside, they look blue, don't they? But most of us know that if we cut ourselves, your blood is actually red. Now, when I was a kid, there was a very common misconception going around that people said that your blood is blue inside your body and then it turns red once it reaches the air. But that's not actually true. It is a darker red inside the body and gets lighter when it hits air, but in fact, it is never blue. The reason why your blood looks blue through your skin actually has to do with how your eyes perceive color. Your eyes perceive color based on the light that is reflected back to them and what light is absorbed. Veins appear blue because blue light is reflected back to our eyes. So when light, such as sunlight, hits your skin, Blue light can't penetrate your skin as far as the red light. So the red light gets better absorbed by your skin and the blue light gets reflected back to you, which is why your veins look blue. Now let's look at sound. Sound energy can be caused by vibrations. Vibrations create sound waves. These sound waves need a medium or some kind of material to travel through. Sound can travel through any kind of matter, solids, liquids, or gases. Try this out. Lay your head on a table and tap on it. You can hear the vibration through the solid table material. So try laying your head on a table and tapping on it. What does it sound like? How do you hear those vibrations in your ear? How is it different when you lift your ear off the table and try knocking on it again? Do you hear a difference? Sound travels through solids the fastest. Maybe you've been underwater and have heard how sound is changed by the liquid. Every day you send sound waves through a gas or air by talking. Sound cannot travel through empty space, which means if you were in outer space and you were talking, people would not be able to hear you. You need air or atmosphere to carry those sound waves. Now you'll see a picture of your inner and outer ear. Let's check that out. How do we hear? Sound is funneled into our inner ear with the help of the outer ear and its useful shape. We can sense strong and weak vibrations with our sense of touch as well. Sound waves cause the organs in the inner ear to vibrate. Tiny hairs in the cochlea continue to vibrate and send messages to our brain. Then our brain decodes everything into sounds we recognize. So here we have our outer ear, and then that tunnel is called the ear canal. Sound waves go through the air and then go into your ear canal. Then they hit your eardrum, which is inside. And when your eardrum senses those vibrations, it vibrates. And your brain can differentiate between all those different vibrations and recognize the sound of a bird versus the sound of your best friend versus the sound of a car coming around the corner versus a car that's really far away. You can sense distance and location and even recognize what that sound is. You can even go so far as recognizing different instruments and pitch to make really complex and beautiful musical melodies. Isn't that incredible? What also boggles my mind is the size of the bones that are in your ear. Check out this picture. These are the bones inside your inner ear. They're so tiny. Look at how they compare to the size of your fingertip. Finally, let's look at sound characteristics. The pitch is the highness or lowness of the sound. A high-pitched sound, like a bird song, has small distances between waves or short wavelengths. A low-pitched sound, like a bass note, has larger distances between waves, long wavelengths. You might remember that from when we played with the spectrometer a few days ago on Chrome Music Lab. The volume of a sound is how loud or quiet the sound may be. A loud sound, like a jet engine, has a high amplitude. The wave would look very tall. A quiet sound, like a friend's whisper, has a low amplitude. That wave would look quite short. So remember, amplitude is how high the wave is. So if somebody is whispering, it's not making as big of a wave as a jet engine. It's just a small whisper. Now, to help you make a connection, I'd like you to walk around your living space now. And I want you to look around as a detective, now with this newfound awareness of all the light and sound waves that are around you all the time. First, let's start by looking for light waves. Can you walk around your space and look at the color of different things? They are those colors because that is the light wave that they absorb. Isn't that incredible? What about sound waves? I would like to encourage you to sit down either in your living space or outside if you can, and try and sit mindfully with your eyes closed so you can really focus on those sound waves. I like to play a game where I try to find and locate 5 different sounds that I hear. And if I can get more than 5, even better. How many different sounds can you pick up around you? How far away are they? Which ear are you hearing them echo through? You probably hear them hitting both ears, but in one ear the vibration is stronger, which tells you that the location will be closer to one ear than the other. This activity not only helps us pause and be mindful by focusing on sounds around us and eliminating other distractions, it's also a really cool way to think about sound waves and all the sounds that are around us and vibrating into your ears all the time. I had fun exploring light and sound waves with you all. I'll see you tomorrow. Bye.